Okay, question number 9, part A. We are given this algebraic fraction and asked to show it can be written in this form and then to find the values of A, B, and C. So different ways to do this. You can do it by inspection or comparing coefficients. I'm going to do it by long division. So we'll write this as x squared plus 0x plus 3 and then divide this by x minus 1. Okay, so we first need to say x goes into x squared, just x times. Then we do x times the x minus 1, which gives us x squared minus x. And then we're going to subtract this from the row above. Okay, so x squared minus x squared is 0. 0x minus minus x will give us plus x. And then bring this term down, which is equal to plus 3. Right? So the 4 steps are, first you divide by the x, times x by the x minus 1, subtract, and then bring that term down. So now we just repeat that process. So we need to say how many times does that x go into this. So x goes into x just once. So that's going to be plus 1. And then multiplying again, 1 times x minus 1 gives you x minus 1. So subtract that again from the row above. So x take away x is 0. 3 take away minus 1, that gives us a remainder of 4. So what that means is, so I'm just going to call this function f of x. So what that means is that f of x can be written as the quotient, which is x plus 1, plus the remainder, which is the 4. So plus the remainder 4 over whatever we are dividing by over x minus 1. Okay, so we have it in this form. So since it says find each of the constants a, b, c, maybe we'll also just write down that f of a is equal to 1, b is equal to 1, and c is equal to 4. Right, so that long division is not that difficult to do. Now the second part of the question is to then integrate this function. So x squared plus 3 over x minus 1 is what we've just shown. We can write like this. So it says hence or otherwise evaluate this integral. So of course we want to use the hence bit here and rewrite this integral into this form. So we can say that we are integrating x plus 1 plus 4 over x minus 1 dx. And we are integrating from 2 to 4. Right, so the first two bits, just x plus 1, it'll integrate to x squared over 2 plus x. Now 4 over x minus 1 is an integral that's of the form just 1 over ax plus b. So if it was 1 over x minus 1, it would have been just ln x minus 1. But in this case, we have 4 over this, so this is just going to be 4 ln x minus 1, right? And ideally, when we integrate and get ln, we should write modulus signs here. Although in this case, it doesn't really matter because we are substituting 4 and 2. So then we just need to substitute 4 and 2 here. Now, if you are using a calculator to substitute this in, if you just plug 4 into all of this, you will get a decimal answer on your calculator. It does say give your answer in terms of ln. So we do have to kind of split this up. So if you're going to plug this into a calculator, you can plug x equals 4 just into that bit first, and then do it kind of by hand for the other part, right? So in this case, I'll kind of write everything out anyway. So we're going to have 4 squared over 2 plus 4 ln 3. And then from that subtract when we substitute x equals 2 in. So that's going to be 2 squared over 2 plus 2 plus 4 ln 1. Now ln 1 is going to be 0, so that will just cancel out. And if you work out each of these bits now, we get when you have x is equal to 4, so 4 squared divided by 2, that gives you 8. 8 plus 4 would give us 12. So this bit would give us 12 plus 4 ln 3. So I'm going to say this is 12 add 4 ln 3. And then subtracting this, so 2 squared is equal to 4. 4 divided by 2 is 2. 2 plus 2 is 4. And the 4 ln 1, that bit is 0. So then 12 take away 4 gives us 8. So this simplifies to 8 plus 4 ln 3.